Good afternoon, friends. I'll start today B31.3 process piping. Eraser design of piping components. I will only say as per 570 API 570. I will not go further for more design. So straight pipes. The required thickness of straight thick section of pipe shall be determined in accordance with equation 2, that is Tm equal to T plus C. So C is the sum of the mechanical allowances, thread or groove depth, plus corrosion and erosion allowances. The minimum thickness T for the pipe selected, considering manufacturer's minus tolerance, shall not be less than Tm. D is the OD of the pipe as listed in table of standards that is given as per code. What should be the OD? D is the ID of the pipe. For pressure design calculation, the inside diameter of the pipe is the maximum value of allowable under the purchase specification. E is the quality factor from A1A or A1B. Quality factor for different types of pipes. E is the internal design gauge pressure. Either you have to find out, either it is given. If T is given, you find out P. E is given, find out T. Depending on what should be the T and required T, you have to calculate from where everything will slowly go. But today I will tell mainly the nomenclatures. S is the stress value and where we can get all these things. Stress value for material from table A1, table A1M. A1 for American system and M is for metric system. A1M means A1 for like KSI, and here means for inch. It is for metric system. It is inch system. Fahrenheit and all. This is for degrees centigrade. The metric system. T is the pipe wall thickness measured or minimum in accordance with purchase specification. T is the pressure design thickness as calculated in accordance with para 304.1.2 for internal pressure or as determined in accordance with para 3013 for the external pressure. So this is 2. We'll see what is in the external pressure, 1.5 times the stress value. So 0.9 times the yield strength tabulated in this part D. So for what we'll see. Then what is W? W is TM. Let's say 30 minimum required thickness, including mechanical corrosion and erosion allowance. W is the weld joint strength reduction factor in accordance with para 302 3.5e. So there is a, if you see from here, you see here it is 47 or you see 20. So anything you can remember depend on you how you want to see in the close, because it is open book. Open book, you need all these things. You have to calculate. You have to do it in a minimum time. So it is up to you how you want to use it. Either you see that 47 or see this 20 and use it, because there is no F key you cannot use there in the exam. It's Control F you cannot use. So weld joint strength reduction factor, that is W. So depend on what you are looking for and what is the temperature. There is temperature if you see, and what is the material. And then you, if it is in between, you can just add and divide, make it for the center. So that is what the code says. Means algebra only use, like if it is in between this, so you can find a number between these two. Let us see the weld joint strength reduction factor W may be determined using linear interpolation for the intermediate temperature values. For carbon steel, W is 1 for all temperature. You don't have to see the table and all. If carbon steel is written, just put 1. Y, the coefficient from table 304.1.1. So you have to see table 3041.1, valid for T less than D by 6 for materials shown. The value of Y may be interpolated for intermediate temperatures, same interpolated. So you can interpolate this. For D, T greater than T by 6, Y equal to D plus 2C, D or D plus D plus 2C. So there is a formula what you have to use. So let us see this 304.1.1. This one, the same 22, and this is 21. So 20, 21, 22, or 48, 49, 50, or 47, 48, 49. What you want to remember, that is up to you. So there is different materials, different temperatures, and you have value of Y, degree centigrade, Fahrenheit, everything given, less than D by 6. Other ductile metals, gray iron, nickel alloys, austenitic stainless steels, ferritic stainless steels. So as per this, we have to put on these problematics. All problems can be solved with this formula here. Thickness or pressure. You need thickness, you need pressure. So you can use this formula only. So T for T less than D by 6. Always you can find less than. It is very rarely greater than D by 6. So if it is greater than d by 6, then it is P by C, less than equal to 0.38 pi. Calculation pressure design thickness for straight pipe requires special consideration of factors such as theory of failure, effects of fatigue, and thermal stress. Okay, for this different, so we are using this one, like T equal to PD by 2 SEW plus PY whole. So that is the equation what we have to use for our calculations. There is another thing, straight pipe under external pressure. So procedure outline in BVP code is section 8 division 1 UG 28 20 30 should be followed using the design length. The running center line length between any two sections defined in accordance with UG 29. All this given 1.5 times the stress value for table take this, or 0.9 times the yield strength tabulated in section 2 part D. So this we are rarely using, but this is we are using very much. Then where you get this S, let us see, E and S. So for E that is table this, and for S there is this table. So these two tables you have to follow. E is only quality factor, so different seamless one, and there is other things there. So the page number you have to remember. I will just go there. I think the first one is this. So let us see. Allowable stresses and quality factor for metallic piping and bolting materials. So it is starting from 182, but there is another thing also you have to see. Basic allowable stresses in tension for metals. So there are, These are for castings. So if you are using casting, different things are there. For metals, this is A1. So starting from 191, if you see here, or if you see here, 164, that is, you see time this, go to the next one. Basic allowable stress S KSI at metal temperature degrees Fahrenheit. So you can get in degrees Fahrenheit in KSI. So into 1000, this into 1000, what you get here as per temperature. So there is a good thing about this here in this Fahrenheit scale. Now, this table is this here. It is written carbon steel and all this. The grade specification number. It's all this given P number. You have to follow, and you find out something. Then the next is 200, 300. Then it is going for 400 here, and the same specification it is continuing, so that you can see there is a first page, there is a second page. Then you go to the next MKS unit. So that is table A1M. So this is for basic allowable stress tensile metals metric. So this is S in MPa, megapascal, in degrees centigrade. This is in megapascal, basic allowable stress megapascal. So if you want to do Pascal, so you have to do 10 to the power 6 and all. See here the difference is something there, you can check it. Like we say start from here 1. So this is for casting, but you can go on rolling, then you get other things. Like this is pipe and tube, you see. So there is 1 to all line numbers are there. So when you go to the next page, your line number will be there and other things you cannot find. That is the problem. So minimum melt strength, minimum tensile strength, and the temperature. Maximum use temperature. So for that, if you go from here, same like that, page number means that serial line number 1, then you can search for these temperatures. Go on searching. So the next page you can see so that is like that. So one page is for all nomenclature and all, and then the next page you go for finding out this MPa at metal temperature degree centigrade. So what you can use, you have to use so while we go through the our calculations, we can understand better. There is basic casting quality factors, that is A1A. You can read this page number 361 or you can go for 334. What you want to remember, you have to remember and remember one so that it is easy. So for me, it is better here. So once you remember or write down to remember in the exam, it is better for calculation. Don't have to search. And this is basic quality factor for longitudinal weld joints and pipes, TOV. For seamless, it is always one. So seamless pipe or anything, it is one. So don't have to bother with these things. But when electric fusion and all different grades, you look for that. So when you see seamless means it will be always one. Don't go for it in the open book too much searching and all. So remember 361, and if you see 390, I think 391. Or 291, sorry. So to find out all these things, and next we go for other one. Let us not move too much around it. When we go, now we'll go for APA 570 2018. So here 7.1 7. Inspection, data evaluation, analysis, and recording. Corrosion rate determination. The owner user may use either the point-to-point analysis method or statistical analysis method, or a combination of both, to determine the long-term or short-term corrosion rates. Point-to-point method, long-term LT corrosion rate of an individual CML shall be calculated from the following formula. Corrosion rate LT is T initial minus T actual, time in years between T initial and T actual. And this is long term, this is short term. No, not the short term is ST, corrosion rate for individual CML shall be calculated from the following formula. T previous minus T actual, time in years between T previous and T actual. T initial is the thickness in inches millimeters at the same location at actual measured in initial installation at commencement of new corrosion rate environment. T previous the thickness in inches millimeters at the same location at actual measured during one or more previous inspections. LT and ST corrosion rates should be compared to see which results is the shortest remaining life as the part of data assessment. The authorized inspector, in consultation with a corrosion specialist, shall select a corrosion rate that best reflects the current process for inspection interval determination. Remaining life calculation. The remaining life shall be calculated from the following formula. Remaining life years, T actual minus T required, divided by corrosion rate inches mm per year. So where T actual is the actual thickness, inches millimeters measured in the time of inspection for a given location of a component that's specified by 5.7. T required is the required thickness in inches millimeters at the same location component as the actual measurement computed by design formulas. Pressure and structural before corrosion allowance and manufacturer's tolerance are added. So this is required, and this is actual. So remaining life you have to calculate. Thank you, gentlemen. I'll stop here. If anything, you can comment. Thank you.